Hello again. Tonight we are going to talk about probability distributions. Last week we talked about probabilities and the rules that have to do with probabilities. But today we're going to talk about the probability of finding, for example, a person who has an SAT score of 800 if the mean is 700, or different issues like that. So there's three kinds of probability distributions that we're going to talk about tonight. We're going to talk about a normal probability distribution. These are the most common that you probably have seen in the past. We're also going to talk about binomial probability distributions. And we're also going to talk about something called Poisson probability distributions. Before we can get into this, we need to talk about something called a random variable. A random variable is just a number that's assigned to every outcome or event in an experiment. For example, a random variable might be the number of refrigerators sold in a store. So X would be the symbol that would denote that random variable. So X could be the number of people that took the SAT. So it's a variable in that the number changes, and it's random because it will change depending on the scenario that you're speaking of. So there are two kinds of random variables that we're going to talk about. And this is important because the type of random variable that we'll use will determine what kind of statistical analysis or what kind of probability distribution we can use. So the two types of probabilities, or two types of random variables, are discrete and continuous. So sometimes you see discrete as categorical. The property of a discrete random variable is that the numbers in that distribution are limited. So for example, number of refrigerators sold, it could be between 1 and 50. So it's a relatively small set. It's a limited number of options that you have within that range. So you could have 1, you could have 2, you could have 3, you could have 4, and often these are whole numbers. This is opposed to a continuous random variable. An example of a continuous random variable could be your age. Your age can go from 0 to whatever, but in addition to that, you're not limited to just 0, 1, or 2. You could be 1.5 years old, 46.2 years old. So another example of a continuous random variable might be height. Another example of a continuous random variable is when you have large data sets. So if you were doing a survey of people in a presidential poll, because you can have a very large data set, that in fact would be a continuous random variable. So for now we're going to focus on discrete random variables. And the first kind of variable we're going to, or random, the first distribution we're going to work with is called binomial. Binomial, what we mean by binomial is that there are only two choices. So you could have true or false. You have yes or no. You could have someone who is late or someone who is on time. So, two outcomes. Flipping a coin would be binomial, because when you flip a coin, you either get heads or you get tails. So what we can do with a binomial distribution is determine the probability of a certain number of events happening out of a certain number of trials. So for example, if we were interested So close your parentheses, hit enter, and the answer you should get is 0.15625. And depending on how your Excel is set up, you might just get a couple digits, or it might be rounded. It might be 0.157, or it might be 0.116. All right, let's try this again. And in a different cell, type in equals binom.dist, and we'll do the same scenario. We're going to find out out of 4 trials, or the probability of 4 heads out of 5 trials with a 0.5 probability, or 0.5 probability, and this time type true. So again, this is the cumulative probability. So what we'll get is the sum of what the probability of 0, which is 0.03125, plus the probability of 1, which equals 0.15625, plus the probability of 2 equals 0.3125, plus the probability of 3, which is 0.3125, plus the probability of 4, which is 0.15625. And the sum of all that is 0.65625. So that's cumulative, and the previous example was not cumulative. Okay, so let's do a sample question. Let's say that a true-false test has 10 questions. So the student's unprepared for this test and randomly guesses the answer for each of these. So part A, what's the probability that the student gets exactly 7 correct? So because this is true-false, we know that this is a binomial distribution. We also know that this is a discrete problem because we have a fixed number of questions. There are only 10 questions on this test. So the way that we do this is in Excel, we type equals binom.dist, parentheses. We know that x equals 7 because that's the number of trials. We know that, or the number of successes. We know that the number of trials equals 10. This is a true-false test, so the probability is 0.5 for any particular question if we randomly guess. And we're not interested in cumulative, we're interested in just 7. So the answer, or we put in false, close parentheses, and hit enter. And the answer that we should get is 0.1172, or thereabouts. Okay, so why don't you take a minute and find out the probability of getting exactly 8 correct, the probability of getting exactly 9 correct, the probability of getting all 10 correct, and then finally the probability of getting more than 6 correct. So pause this video, take a minute and figure it out, and then come back and I will discuss the answers. Alright, so using this command, the probability of getting exactly 8 correct is 0.0439. The probability of getting 9 correct is 0.0098. The probability of getting 10 correct is 0.00098. And so then the last thing, the probability of getting more than 6 correct, would be the probability of 7 plus the probability of 8 plus the probability of 9 plus the probability of 10. And the answer to that is 0.172. You might be slightly off because of a rounding error. Alright, so the last question of this is take a minute and see if you can figure out the probability of getting 6 or less correct. Pause this video and then try it out on Excel and then come back and we'll figure out what to do. So the way we do this is, again, we use the binomial distribution. We want 6 or less, so we're going to do 6 out of 10 with a 0.5. But in this case, we want a cumulative because we want the probability of 0 or 1 or 2 or 3 or 5 or 6. So we're going to type true. And what we should get is 0.828. And then remember also, if we take all of our probabilities for a particular set of tests, they should equal to 10. So if this is 6 or less, if we add 7 or more, which is 0.172, this should equal 1.0. So that's the conclusion of binomial distributions. Next, we're going to talk about the normal distribution.